In this video, I'll introduce you to overriding methods in the superclass. Subclasses may implement methods that already have implementations in the superclass. In these instances, the methods in the subclass are said to override the methods from the superclass. For example, although a field called color code is in the superclass, the color choices may be different in each subclass. Therefore, it may be necessary to override the accessor methods, getter and setter, for this field in the individual subclasses. Although less common, it's also possible to override a field that's in the superclass. This is done by declaring the same field name and type in the subclass. Now, keep in mind that only non-private fields and methods can be accessed by a subclass, so public and protected methods and data can be accessed or overridden, while private methods and data cannot. Let's take a look at these classes. Inheritance lets programmers put common members, fields, and methods in one class, the superclass, and have other classes, the subclasses, inherit these common members from this new class. An object instantiated from a subclass behaves as if the fields and methods of the subclass were in the object. So the shirt class can be instantiated and have the getPrice method called from clothing, even though the shirt class doesn't contain a getPrice method. The trousers class can be instantiated and have the display method called from clothing, even though the trousers class doesn't contain a display method. And the socks class can be instantiated and have the getID method called from clothing, even though the socks class doesn't contain getID. They're all inherited from the clothing class. This code demonstrates the display method for the clothing superclass and also the getter methods on lines 35, 38, and 41. And one of the setter methods on line 44. The remaining getter and setter methods aren't shown here, but let's assume that they're there. The display methods used in lines 30 to 33 print out only fields that exist in clothing. Think back to the last diagram where we saw the superclass clothing with all its various methods. In order to display all of the shirt fields, you'd need to override the display method in shirt. Notice that the display method overrides the display method of the superclass and is more specific to the shirt class because it displays the shirt's getFit property. The shirt class doesn't have access to the private fields of the clothing class, such as item ID, description, and price. The shirt class's display method must therefore call the public getter methods for those fields. The getter methods originate from the clothing superclass. The setColorCode method overrides the setColorCode method of the superclass to check whether a valid value is being used for this class. The method then calls the superclass version of the very same method. So when we use the override method, what happens at runtime? First, the shirt1.display code is called. The Java VM then looks for display in the shirt class. If it's implemented in shirt, it calls the display in the shirt class. If it's not implemented in shirt, it looks for a parent class for shirt. If there is a parent class, clothing in this case, it looks for display in that class. If it's implemented in clothing, it calls display in clothing. If it's not implemented in clothing, it looks for a parent class for clothing, and so on. This description isn't meant to exactly portray the mechanisms used by the Java VM, but you may find it helpful in thinking about which method implementation gets called in various situations.